We might not notice, but tremendous technology and mind-boggling science constantly surround us in the products we use every day. Behind their practical use lurk hidden histories, dramatic discoveries, and awesome experiments. They are Wicked Inventions. Coming up, sports cars. Can you make a high-performance car from a tree? Concrete. What makes this fantastic material the second most used substance on Earth? Combine harvester. We find out what winnowing means and why it is so important to harvesting crops. We reveal the surprising science and amazing manufacture behind these wicked inventions. A sports car is designed for performance and handling all types of twisty roads and conditions. But just how were they introduced? The roots of the sports car can be traced back to the original automobile designed by Carl Benz in 1885.
Well, ever since Benz introduced the first kind of cars, there was a desire for people to drive them faster, to have more manoeuvrability, and also a race scene emerged. As soon as we became automated, there was a competitive element.
In 1886, Benz applied for a patent for his vehicle powered by a gas engine. His application was successful and is still regarded as the birth certificate of the automobile industry. In Britain in 1913, a car appeared that would lay claim to the title of the original sports car, the Vauxhall 1398. However, it wasn't until the 1920s and onwards that we really saw a separation from the average road-legal car.
It was really Britain which led the way in democratising sports cars and creating the kind of classic shape, the kind of classic lines, look and feel which we now know today. So what are the ingredients of a British sports car? Well, usually they're characterised by being slightly smaller in body, usually slightly further back if you think of some of those classic Jaguars, where you were really quite far away from the front, and kind of a light, small chassis. That's the classic British sports car.
Despite great technical innovations in auto design and manufacture, time and again designers have returned to the stripped-down simplicity and heritage of the traditional sports car to seek inspiration for future engineering designs.
Right up to today, that kind of classic look and shape, the small two-seater, hasn't really changed and is now something which is copied around the world.
The sports cars of today have followed the characteristics that made their predecessors so desirable and fun, with companies such as Morgan creating cars that capture the essence of the true sports car. But just how are they made? The Morgan Motor Car Company is famous around the world for still including wood as an integral part of their car structure and design.
Morgan Motor Company was established in 1909. We make British sports cars, we make 3- and 4-wheeler cars. What makes Morgan special is the differentiated and the materials we use, the way we make the vehicles. Using wood is unheard of today in motor vehicle manufacture, and I think that's what makes the vehicles very special, along with the level of craft that we marry with our technology during the build process.
Wood comes into the factory and is cut down to size using a bandsaw and sent to different areas of the mill. To create the iconic wheel arches, planks are glued together using a strong bonding agent and placed into a jig, which holds them in position as the glue dries. This process has been used since Morgan began in 1909, with the only changes being to speed up the time taken for the glue to dry. It used to take several hours, but modern materials have reduced this to less than 1. Notches are cut and chiseled out of sections in preparation for when the frame is assembled. These notches will connect with others in different parts of the frame and will strengthen the overall design. Elsewhere, different cuts of wood are being joined together. Glue is used as the primary hold before metal screws are inserted to make sure the joint is strong. Spindle moulder tools are used to put a smooth, curved edge onto touch points of the car's frame. 40 minutes after the planks were placed into the jig, the glue is dry and they are ready to come out. These pieces are hung on the wall in the detail area to have excess glue trimmed and the edges refined.
And a lot of people quite often say when you're making a car in wood, what happens in a modern world when you crash? But it's actually, because it's a live material, it absorbs energy. So it performs, not only is it a good material to use whilst you're building the vehicle, but it also performs well through the crash principles of vehicle manufacture.
In the chassis shop, the main chassis components have been welded together to form a ladder frame, a design that hasn't changed since the 1930s. The engine and engine bay wall is fixed into place before the suspension, drivetrain and brakes are all added. This means that the car is ready to rest on its wheels for the very first time. Since the wooden frame is made by hand, their size is unique, which means that the aluminium panels that make up the rest of the body are too. In order to get a perfect fit, the frame is positioned onto the chassis and the edges trimmed to its unique shape. Panels such as the bonnet have key details that must be mechanically and aesthetically perfect. These are made by expert craftsmen who have refined this skill over many years. The edges of the panel are then knocked and rolled over to give it strength and a smooth edge. Now it won't fit any other car. At this point, the wiring loom is added to provide electrical circuits throughout the car. In order to protect the car's metal bodywork from the weather and other harsh elements, it needs to be painted. In the paint shop, panels are removed from the car and hung up, whilst the wooden parts of the car are covered with plastic sheets. The panels are sanded down and coated with primer, before an operator uses a paint gun to spray the panels with the chosen coloured paint. Morgan has over 40,000 different colours to choose from. Once painted, the panels are moved out of the paint shop to dry, where they are inspected and polished. Next for the car is the trim shop. Here the leather and carpets chosen by the customer are cut to shape using stencils and templates. Covers for the seats and dash are sewn together with strong thread and fitted before glue is used to stick the material to the car's frame. The trim is made up of lots of small pieces of leather to ensure a tight fit to the car frame. Finally, the car's painted body panels are reattached, and key interior items are fitted, such as the dashboard and steering wheel. At last, the car can be driven, and so is taken for a test drive. This makes sure there are no components that rattle or knock, and that all the dials and controls work properly. If it passes, the car is prepared for the customer by thoroughly polishing and cleaning every part. The car is inspected in a light room, which would show up any flaws that are then treated. A final check is performed to make sure each car perfectly matches the customer's specification. Then, 3 weeks after the build process first began, the car is handed over to a happy customer. The sports car, truly a wicked invention. It is a material that has a rather boring reputation, but its amazing properties are actually responsible for creating some of the most awe-inspiring and iconic structures and buildings the world has ever seen. We might think of it as a modern invention, but concrete has been used by architects, engineers and builders for a lot longer than you might think.
We think of concrete as a modern invention. It's not. It actually was discovered about 12,000 years ago, and at that point it was used as possibly a reason for bringing people together, because once structures were being built, towns started to conform, and this was about 12,000 years ago in Turkey. Even 8,000 years ago it started to be used to build underground cisterns, and the Mycenaeans used it to sort of build more cisterns and wells, and so it's been very, very used in antiquity.
Arguably one of the most famous early civilizations to master the use of concrete for building was the Romans. By 150 BC, a concrete material which was created from burnt limestone, volcanic ash, rubble and water was being used to transform the landscape and stamp the authority of the Roman Empire all over their world. The magnificent Pantheon in Rome can sum up their mastery of concrete. Completed in 128 AD, it still has the honour of being the largest unreinforced concrete dome in the world. So, why is concrete so useful?
Concrete is a very useful material. It's very hard when it sets, but in order to make it, you mix it up and pour it as a liquid, so you can pour it into any mould, any shape, and any design you wish. So you can make buildings that have elegant, curving structures that you could not make with bricks, because bricks have the inherent property of small units that are held together with cement, but unfortunately it's not one complete solid structure. That's one of the big advantages of concrete, that it can be one solid structure poured continuously, and some systems are designed for continuously pouring a building, so the building is setting at the bottom and is being poured at the top as you go up, and it effectively becomes one complete structure.
The use of concrete declined from the 6th century with the fall of the Roman Empire, but gradually reappeared as a popular building material from the 17th century onwards. Today, it has become the second most widely used material in the world behind water, with an estimated 1 tonne of concrete used for every person in the world annually. That's over 7 billion tonnes. So, what is concrete actually made of?
Concrete is a mixture of water, sand, stones, and cement. It's essentially a mineral, and it's a chemical reaction. What happens is, when you add the water to the cement, this starts to react. And as it reacts, there's a certain period of time in which it can maintain a liquid structure, which you can pour into the right place. But thereafter, it will react fully, solidify, and basically be as hard as rock and as hard as stone, but still very useful for building structures. There's often a lot of worry about how well the concrete is mixed, because if the concrete mixture is not correct, what happens is if you add too much sand, it becomes brittle. If you add not enough sand, it becomes hard and then also can crack more easily, which is the problem if you're in earthquake-prone zones, or if there's just a lot of traffic producing lots of vibrations on a motorway. You don't want the structure to collapse.
The conversion of calcium hydroxide in the concrete into calcium carbonate from the absorption of carbon dioxide over time strengthens the concrete and makes it more resistant to damage. This means concrete continues to strengthen for decades, although 90% of its final strength is reached within 4 weeks. So, what makes concrete the material of choice for architects and engineers?
A lot of modern buildings benefit from concrete because it acts as a very excellent insulator and means that you can be sound insulated, you can have thermal insulation. It's fire retardant. It doesn't burn. It absorbs a lot of heat, but it also means that you can build a very safe house from which, if a fire happens, it'll only happen within the small structure in which it's contained and not spread very rapidly. Because concrete is effectively a stone and a mineral, it means that it'll crack, but it won't necessarily cause a fire itself, which means that it's safer for people to live in.
Today, reinforced concrete is probably the most popular method of using the material. This technique uses steel rods that are encased in the concrete, which gives the material high tensile strength, and was used in the construction of the Three Gorges Dam in China. This 1.4-mile-long dam holds the world record for the largest concrete pour in a single project. A mind-blowing 16 million cubic meters was used over 17 years. Unfortunately, using steel rods in concrete is not without its own dangers. As concrete can naturally crack over time, water can sometimes make its way inside the structure, and the rods may begin to rust. When steel corrodes, the resulting rust occupies a greater volume than the steel. This expansion creates tensile stresses in the concrete, which can eventually cause cracking, delamination, and in extreme cases, the structure to fail. To combat this problem, engineers and scientists have come up with ingenious solutions of allowing a building to heal itself.
One of the more promising developments is looking to encase bacteria inside small crystalline material, mix that as part of the concrete mix, and then as water comes in, it dissolves the outer casing and the bacteria react to the water and they produce limestone, at which point that seals the cracks and keeps the concrete essentially crack-free and maintains the integrity of the concrete, thus ensuring the building's longevity.
Concrete. Truly a wicked invention. We've seen how concrete is fire resistant, but what about a balloon? Put a flame near a balloon and... Let's stop this happening. We're going to need a balloon, a candle, a syringe, and some water. We fill the balloon up with water. We then inflate the balloon and tie it off. We light the candle and we're ready to go. We place the balloon over the candle, ready for the inevitable explosion. But nothing happens. The balloon doesn't pop and we are just left with a black spot where the flame has heated the balloon. The secret is the water, and more importantly, its ability to conduct heat. The thin latex balloon allows the heat to pass through very quickly and warm the water closest to the flame. This water heats up and rises, with cooler water replacing it, which in turn is heated and then rises. This cycle keeps on repeating itself, so often it stops the balloon from popping. And the black spot on the bottom of the balloon, that soot is actually carbon that has been deposited on the balloon by the flame. You can wipe it off and see that the balloon is undamaged by the fire on the bottom of the balloon. The carbon was deposited on the balloon by the flame, and the balloon itself remains undamaged by the fire. Can we make a balloon fire resistant? Yes, we can. Wicked challenge smashed. The combine harvester makes the process of gathering crops more effective than ever before. But just how and why were they introduced?
Their history obviously comes from man's natural need to gather food. The name is a combination of all the functions a combine produces. Obviously there's a lot of oats and a lot of barley, so the need to gather it all in quite quickly and efficiently was quite pressing.
Some of the functions a combine completes are reaping, which is the simple cut and gathering of crops; threshing, where the grain is loosened in order of separating the edible part of the grain; and winnowing, where the remaining mixture is launched into the air so that the lighter chaff blows away while the heavier grains fall back down for recovery.
The first step on the ladder of the combine evolution was a Scotsman called Patrick Bell in 1825 who created the first reaper.
From this, we then saw the addition of other methods like threshers. This is when we began to see the mixture of harvesting processes being combined together, which saw the increase of productivity. In the mid-1830s, the first combine was invented by Hiram Moore. These early combines were usually driven by horses. However, it took several decades before the combine became a common sight.
And really, as America grew, you start to see people using this kind of machinery more. Obviously, land, ranches, farms got bigger, crops got much, much bigger, and the work of 10, 15 men could be done by one unit. So it was really around the 1920s when you see the evolution of the motor industry. Trucks would be adapted, and eventually that kind of technology would move across to the harvester.
Most combines are now equipped with comfortable seating and full air conditioning. The inside of the combine can also be slightly pressurised, which does not allow dust and dirt to come in. But just how are these wicked inventions made?
Here at Claas, we are building combines since the 1920s. The latest product that we have, our heavy product line, is the Lexion combine. The Lexion combine got introduced in 1959. Since then, we have produced here in Hazewinkel more than 50,000 combines.
Once all of the cut metal parts have been delivered to the assembly line, the production of the main body of the combine harvester can begin. This will become the core of the machine, housing the all-important reel. This reel will slowly rotate and push the crops towards the cutter.
It takes for a combine on the Lexion line, in the assembly lines, it takes between 80 hours and 120 hours for a machine to assemble them.
As well as this, the fan box and the sieve box are assembled. This fan box will blow the crops through the combine harvester. The sieve box is vital as it separates the grain from the crop. Once this unit is complete, it is carried to the main assembly line. On this line, all the components that will make the combine harvester work come together. Axles are bolted to the body and wheels are fitted to the axle. As a sub-assembly process, the highly powerful engine is then fitted to its cooling box. This can then be added to the combine harvester on the main assembly line. The rotor housing for the combine can then be assembled with the cleaning box. These modern-day combines are able to clean the grain as they process it, and this has become a vital function of the machines. At this stage, all of the belts that will give the combine its drive are fitted. These will spin the rotors amongst other functions, such as driving the grain elevator. The pace is picking up now, and our combine harvester is coming together nicely. As it moves down the line, with parts constantly being fitted with great speed and precision, the grain tank is fitted to the machine, as well as the cab. The cab is where the combine harvester operator will sit and has access to all of the combine's functions. It is raised in a high position and is mainly transparent to give the operator a wide field of view.
Throughout this whole production process, we have several, we call them quality gates and quality checks. So we make sure that one area only delivers good quality to the next area.
The hydraulics of the combine harvester are fitted here too. Many of the functions of the machine are powered via hydraulic oil, such as the hoses and feeder house. Along with this, the engineers assemble the clean grain elevator. When the combine harvester is operating, the clean grain elevator will carry the grain to the grain tank, where it can be stored.
In this basic assembly, we put all the functions of the machine together. So at the end of this basic assembly, you could use the combine and go into the field.
The assembly process isn't far off completion now, and the first testing process can begin. During this test, the engine is powered up for the first time and the revs per minute are analysed. The hydraulic system is tested, as well as the grain and feeder systems of the machine.
Second area is the test area, where the machine gets started the first time. We are testing all the functions. And then we are going into the final assembly.
From here, only minor assembly actions are needed, such as final electronics fittings.
The reason why the test area is located in the middle is that this way it is easier to test all the functions or to do repairs.
This combine harvester won't get too far without its main wheels though. Once these have been fitted, the combine can undergo its final testing. This is an extremely thorough process that enables the engineer to know that their machine is faultless. With final testing complete, the combine harvester is ready to be put to work on fields and farms worldwide. Combine harvesters, truly a wicked invention. So, there you have it, a dash through the hidden history, super science, and amazing manufacture of products that you use every day, but have never realised their amazing backgrounds. Sports cars, concrete, and combine harvesters. All wicked inventions.